we've just been showing this video to. I've just been showing it to you really because I just went live, and we'll just let this bang bang scene finish, and then we will switch. It looks like we are in. And hello everybody, how's it going? Welcome to JSFX Scripting part. It's a part. It's definitely 10, 11. We've been doing this a while. Part 11. So I'm really happy that we've been doing this a while now. And, you know, we started with Lua. We're going to return to Lua as per the request of a few people who said, like, JSFX is getting a little bit over their heads. So we will be returning to Lua. And actually today we have a easy thing in mind. It's not going to be writing an EQ, which is, you know, lots of math. It's not going to be like calculating RMS or anything too crazy. It's going to be a very, hopefully, simple thing that we've done a little bit of the work on. I guess I should say, with me as always is the wonderful Leandro, aka leafac.
Hey Aria, great to be here. Thanks for having me.
Yeah, of course. Thanks for being here with us. So, Leandro, I had this idea a while ago that I pitched to you, and we just flipped a coin to see whether we should do that idea or another idea. And that idea, the gods of randomization chose that idea. So we are going with that idea.
Yes. Tell us all about it.
So this idea is about this, right? So I want a ping pong delay, but I want a ping pong delay that's actually a ping pong delay. Or I should explain. I should explain that the first time I heard of the concept of a ping pong delay, I didn't. I imagined it being different than what it actually is. Because a ping pong delay is a delay that goes left and right, like when two people play a ping pong. But what I actually thought a ping pong delay does is a delay that makes a sound like when you drop a ping pong. And at the beginning, it's slow, and over time it gets faster until it almost turns into a pitch at the end, like ta 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 ta, right? So then I saw a ping pong delay and I was like, well, this sounds cool, but this was not what I was imagining. So then I thought, well, and then I wrote a lot of music around this idea, like how can you in notation write notes. And I did a bit in my university about this, like how can you write notes in a way that each note is like a proportional duration to the next, but not a symmetric half proportional, but like the first one is 100% and the second one is 80. Then it's 20% of 80, which is terrible math, 16 less 74, and then 20% of 74. So it sounds like, whoops, I gotta get a good surface for this. I'm gonna turn my mic this way. Well, I gotta also drop it straight. Yes, that sound.
That sound is amazing. Yeah. Okay, so the first thing we have to do is to get a good take of this sound. Because when we are done with our delay, we need to compare it to the real world to see if we modeled the real world correctly. So do you think you can set this up, put a microphone on the desk and actually record this sound?
I can do that. And what do you think? If we're being real nitpicky, I'd be inclined to grab my other mic and do it. Or do you think should I just use the SM7B?
Yeah, whatever you have handy, because it will not really be used for anything besides comparing to the thing we come up with.
All right.
I mean, it's almost like a high school physics class, what we're doing.
And I wish I had a good camera so that I could show this and it would be more entertaining. But alas, yeah, alas, this be what it be. So I'm going to do that, and I'm going to hit record.
And I'm going to watch. And Bo is on the chat. Hey, Bo. And he's saying that it's a cool idea, but more JSFX. Yes, this is going to be JSFX. You are not going to be disappointed. Yeah, we are going to do some real-time audio processing here. It is going to be a delay with a crazy amount of taps in weird positions.
No, fail. I need more surface. Nope. Nope. You gotta just be real straight. No. That one that I got was really good. I should go record the stream actually. Don't go that way, just stay. I do have a theory that my house is crooked.
Yeah. And Andreas is here. Hey, great to have you. Is this the man who appeared on Kenny's channel, Epic?
Hi, Andy.
Is this the man who appeared in Kenny's channel?
You don't know? I was on Kenny's. I did a video on the Kenny Joya channel yesterday.
Oh, I didn't know that. What is the video about?
Introduction to SWS.
Oh, so I saw that on my timeline. I didn't know it was you.
And actually, it's been really nice because I got 260 subscribers in one day, which is usually the amount I get in 1 month or in 4 weeks.
So oh, pretty nice. That is amazing. I have almost that amount of subscribers at all.
All right, let's try the floor. And hopefully it's loud enough. Otherwise, I'll grab the other mic. I wanted. That was very good, actually. I think. You know that end when it like turns into a pitch? That's really kind of like what I want to capture. So let me try one more time. Our house is crooked, I'm telling you. This entire city is.
The entire city is crooked. And Andreas says, you say that as if it was a normal thing. Which part? To get 200 subscribers? I guess it's normal for Arya. It isn't for me.
Oh, I mean, for me it was...
And having 200 subscribers at all, I think it's kind of a normal thing.
Yeah, no, for me it was a surreal dream too. I actually, like... There's this thing called, like the live, what do you call it? Like a live subscriber update feed. I never even turned that on because it's not like, I mean, the growth of my channel is not visible to the naked eye. Maybe if you're like a binging with Babish type of creator, you would be able to see that number like go up. But for me, it was never relevant. And then when Kenny published the video, I captured with OBS the 24 hours of the feed, and I'm going to speed it up 1,500 times and publish that. Yes, being on Kenny's channel was nice. I don't think it's happened before, so that is dope. That was really dope. And of course, Kenny and John Tidy are both just the nicest people ever. They've been so helpful. John sometimes puts me in his like newsletter that he sends out to his mailing list, which is really nice. Always helpful. And I actually feel really bad because John Tidy is streaming right now, so we shouldn't be streaming. But yes, yeah. Sorry, John. I know you don't stream when we stream, so I just feel like a piece of crap a little bit.
It's all right. We can make it up. We can, instead of doing the ping pong delay, we can watch his stream and comment. And we can all watch together. No, really. Let's talk about this ping pong thing. This is a great recording that you have there. We can clearly see each spike and we can see the decay in level. This is perfect. And this is what we want to model.
Yes.
So I have an idea of how I want to go about this. Do you have an idea of how we should do this?
Well, I mean, I have a rough idea because if this was max MSP, I actually wrote this delay in max MSP. And in max MSP, you have this thing called tap in and tap out. They are two objects that you connect to each other, and it creates a feedback loop. And then you can give them an arguments like rate and stuff like that. And you could have basically like multiple of these, and the rates would be something like $1, and then the $1 would be a separate parameter that you would input somewhere else, such that whatever value you input, it would put that value in the first feedback loop, it would put 90% of that value in the second one, and so on. I did also create this as a ReaFIR delay chain, because in ReaFIR delay you can do this. But I organized, quote unquote, my my effects, and that means that now I don't know where they are, because before, when they were not organized, it was a lot easier to, like, where did I put it? Is it in sound? Did I think that sound design? Yoink FX, Mega Chain, Servo, Dreamy, no. Oh, I think it's just the ReaFIR delay preset, actually. ReaFIR delay presets. Yes, Andy, and I don't think anybody else has been on Kenny's channel as a guest host. Maybe I mean, he is trying new stuff, right? Because he's also now showing his face, so maybe that kind of thing is, maybe that kind of thing is gonna become more commonplace. But anyway, let me show you my ReaFIR delay preset too, and then we'll get to coding. So my preset goes, which is not very good. I made a few of the.
Can you render that track?
Actually.
Yeah, I actually want to see things. The more I work with audio, the more I want to see things.
That's kind of my best attempt, but really, to get it to be good, you gotta use I don't know what that sound is. Why are you doing this?
There is some tap in the delay that has some feedback.
Okay. Any hoozles. I can render this. What's the best way to do this? I'm gonna do this the old school way.
Okay. I usually right-click on the track and I go like freeze or render or something.
I find that this method for shorter things takes a little less time. So I think mine works until this point. Then at this point, I just realized how many taps I need, and I kind of yeeted the rest of this operation. Though also with this, I was going for a musical rate. So this whole thing does take 2 measures. So that's kind of nice. But yeah, so that's the fake ReaFIR delay. That's one of the fake ReaFIR delay parameters that I created. But of course, this is done manually, right? I manually went and did 4/8 notes, then 7, then 9, then 10, then 10/5, 10 and a half, 1075, 1090, 1095, and 11. So, and
the intent is that as these steps go on, they become quieter. And I think I saw that when you were moving through the tabs, they become quieter.
Yeah, I even, like, with ReaFIR delay, I have a little bit of, I don't actually make them quieter, but I do filter them, low pass and high pass.
Okay, so that's something we can do as well.
And I increase the width, which is also nice. So at the beginning, the first one is mono, and then it kind of spreads out. So it's a nice, it's a good thing.
It is nice, yes. And I think that the basic idea is there. I mean, we don't want to detect transients to actually pretend that we have a ping pong ball going. What we want is just have a delay where the taps are spaced out in a way that is going to, if you just have a transient going through, it will seem like a ping pong ball, but you could use it in something else, like, I don't know, some kind of pad.
I was gonna do a demo. Something like this, right?
Yeah, I could barely hear that. I'm not sure if you're feeding me the same audio you're feeding the stream, or if there's
that would be
something
lame if I
something else going
wasn't
on.
feeding y'all, and I am indeed not. What's going on? I thought I did a sound check, but I guess I did a shitty sound check. I know what it is. I had to not forget to restart because my black hole, not the black holes that you made for me, but the black holes but the 16 channel black hole keeps screwing up. Oh no, it's not screwing up. I'm an idiot. There we go.
Okay. You know about black hole? One thing that I do every time I stream is I restart core audio, so it restarts all the black holes, because I find that they often crash. So I just put it on my script. I have a script that I run every time I want to stream that resizes my monitor and that does a bunch of other things, sets up the audio routing and everything. And now it's also restarting core audio.
That's cool.
Just in case.
You're living in 3021, Leandro.
No, I wrote a 10-line Lua script. We know how to do that.
Spoon, right? You hear that now?
No, I don't.
What the scheisse? Oh, the stream hears it.
But the funny thing is,
The stream hears it.
Oh, okay. So maybe
no,
it's just
but
me.
I can't make you hear this in one quick move. Are you ready for it? Shazam! You still hear me, correct?
Okay.
And
yes, I do hear you.
Do you hear that?
Yes, I do. It's great.
I don't know why I went to C#.
It's not only a novelty, it may actually be useful. I'm impressed.
Yeah, well, okay, so while we're on the subject, I'll show you one more thing, and then we'll really get to working. This is kind of like the motif. In most of my new album, there's like references to this motif. So I can show you one small section of one of the songs where I think is the best, like the best sounding part of me using this implementation. This is the demo version, not a finished song, but I'll show you that and then we'll get out of here. Let's see, is it here? No, I think it's here. Yeah. So this one is actually played, but then later a keyboard comes in, and that one is with this ReaFIR delay. No, I went too far. It's coming up. Like that. You hear that like faint kind of Rhodes keyword in the back? That's going through this ReaFIR delay thingamajig. Yeah. But this is not the exact one. But yeah.
Awesome. Now let's build this. Let's do this. Let's do this JSFX thing.
Let's get into it.
So I guess the first component we need to store samples so that we'll be able to replay them later. Now, do you want to do this from scratch or do you want to use my library? Because that part of my library is already working.
I want to use your library.
And to do it from scratch is super trivial.
We did actually write a delay line when we were with Garant, if you remember, a while back.
We did,
but
yes.
I want to use your library.
Yeah, we did it, but then we decided that it was not worth using it because it was so simple. In fact, on that delay line, if I remember correctly, we were not able to tap arbitrarily. In the past, we were only able to tap, like if the delay line was of 5 seconds, we could only tap 5 seconds. We couldn't tap like 2.5 seconds. And then we decided to, for the reverb that we are going to work on eventually, we decided to just use his library instead. But now that we have my library, we can use that as well. And my library has a different trade-off in terms of speed and flexibility, but I'll not get into that. It's just a matter of, do you want to write a delay line real quick? It's not too hard. Or do you want to use mine? Or do you want to use his?
I want to use yours. And for those of you who may not know, tell people what your library is and tell me how to download it while you do that.
Okay. So how to download it, you have to first wait for me to push this. I haven't pushed this in a while, so I'm gonna do it now. And what this library is it's a JSFX library that allows you to do many things that you need in terms of digital signal processing, but it's not done by any stretch of imagination. I'm still very in the early days of working on this library. And then besides the digital signal processing stuff, I'm also going to add some a design system, some colors and spacing and all those kinds of things that you need to do good looking user interfaces. And I want that to be easy to use. So I want to have a library that will both help you in terms of sound as well as in terms of interface. And I want the effects that people develop with this library to be visual. I want it to be like FabFilter-like. I want you to see what's going on in the audio. I'm very much a believer that you should mix with your ears and with your eyes. So that's what this is about. And as I said, it's still very, very early in the process of development. So most things are not working, but one thing that is working is the delay line, and we can use it. So I'll stop speaking and I will actually push so we can download this on your machine.
Bo says, could I try singing using that delay? I mean, could I try singing already? I'm really bad at singing, but I will do that. Yeah, sure. It's a matter of also I found just overall kind of experimenting with the album, it sounds a whole lot better. I'm going to just get a little bit organized here. It sounds a whole lot better when you are doing like something that has like an upfront transient versus singing something like, ooh, kind of deal. But yes, I will try singing for ya. Yes, I'm just kind of getting organized. I want to put these in ping pong sturf. And this will be me singing. Boop, bop, whoops, I'm not armed in the correct track. Zoop, bop, beep, boopity, boop.
I'm not hearing the delay.
No, you wouldn't yet because my monitoring is off, but now you shall hear that. So let's do it one by one. This one clipped. Zoop, 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 zoop. It sounds very distorted, actually. I'm gonna turn this down. Cause yes, I am now like cranking my mic because I can't use my second ReaFIR anymore to get a nice gated zoop, 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 and the like more kind of like singy songy element. No, you would. No, you would. No, you would. No, you would. That doesn't sound half bad, actually. I mean, imagine if I was a proper
it's
singer.
nice.
Imagine if we implement.
The thing I like about this idea when it's like when you showed us in the. I think in your song in the beginning or in some other example, it felt like the thing is like falling apart and breaking. And I really like the sound of that. Okay, so I uploaded the latest version of my library, and you can go to the link that I sent on Skype, or I think I saw you opening my ReaFIR repository on GitHub, so you can do that as well.
I'll do that just so people
and either way, you're
see
gonna find this
So
file.
I'll go to ReaFIR.
Yes. And then go to effects.
And I'll put the link in the description.
And then it's called, yes, this one, leafac JSFX Inc. And this extension means this thing is a library.
I gotta go to file, right?
No, just click on the file name. And then click on raw.
Raw.
And then save this to the folder where you want to work in your effect.
I will be pasting this link in the. If I just paste this raw link in the chat, people can just save that, right? Cool. I'm gonna put it in FX, and I may have a leafac folder already. I have a Leandro Facchinetti folder.
Well, you may not want to put things there because this is a folder managed by ReaFIR.
Just put it in effects.
Or create a folder in there. That's what I would do.
I should since I have like many, or not many libraries, but I have a grand total of 2 libraries. I should make a libraries. Wait, this is text. This should not be text, right?
Yeah, remove that extension.
Oh, just nothing?
No. Yeah, there you go. That. Remove the text
still
extension.
Kind of saved it as a text, but let's go to this directory and make sure that .txt is not there. It is there. Thanks for listening to me. All right. And I will need to import this into ReaFIR. Let me put this in the chat. Is it possible to do a smearing, blurring thing with the delay to get a reverby feel? That's one thing I want to do. Also, when you said do vocals, I was like, well, if the vocals were pitch shifted, like maybe go up and down in pitch, that could be something dope. But I'm assuming, I guess let's just start with the basics and then we'll pimp it out later.
Yeah. So create a new JSFX and let's take note of all these ideas we have.
I'm going to call this leafac, IDDQD, Bo, or just Denarius, I guess. Why not? And the F is in here. And I'm going to call this the real ping pong delay. But then people think it's just a ping pong delay. I'm going to call this the ball drop delay, and the ball delay. The ball delay, and then people will be like, what? Yeah, okay, cool. And I'll edit this, and I will make this so that the chat will see a maximum amount of it. That looks good. And I'm going to call this the ball delay. And let's put some comments here. Oh, what was it? Is it like this? I always forget. How it's the...
Either one works.
I guess just because I want to write a bunch of stuff.
No, but it is slash asterisk and then it is
slash,
asterisk slash.
So okay. So ideas. So set one rate, auto sets other rates. That's, I guess, the whole whole shtick. Could be, Leandro, I'm being real ambitious here. Could we set a velocity or maybe a height? So if it's...
That's what I was thinking. I was thinking of this from a high school physics perspective. Or depending on where you go to high school, it's actually more like on my high school, I didn't learn the things that we're going to use today. I learned these things at university, but I know that in the States, they call it pre-physics or whatever, and they teach this stuff in high school. In any case, it is going to be some elementary physics thing, but I thought that the controls for this would not be something like rate. It would be more like height. How far from the desk are you letting your sound fall? And then we could also change the gravity. I mean, we are going to start with the gravity of Earth, because we want to match that sample that you collected, but we could have a setting that is going to make the gravity stronger or weaker, and then the ball would fall faster and it would stop earlier. So I think that all those settings could be fun. Like, what does a ping pong ball sounds like on Mars?
Oh, that is the shit.
Go to Google, you find the gravity of Mars, and then you plot it into the thing, and you're going to sound like you are in Mars. And I think that is fun.
I wonder if you...
And you could also change the...
I wonder if you drop a ball... Well, Jupiter is a bad example because Jupiter is gaseous. But let's say you drop a ball in the sun. When it falls on sun, it immediately starts to oscillate because the gravity is so severe. It probably won't oscillate, but that would be cool. Like, you drop it and it immediately goes brrrr.
Yeah. So we could have presets that are like Earth, Jupiter, Sun.
Lovely.
And then we can also change the material of the ball, because the material of the ball determines how much it's going to bounce when it kicks. If the ball is like a ping pong ball, it is going to bounce a lot. But if it's more like a marble, it's going to bounce less because it's denser.
And higher amplitude, right?
We can have a setting for that as well.
It will be a higher amplitude as well as a result of being... do you know what I mean?
Correct. Yes. The amplitude of the sound coming off, I think, is proportional to the moment of the movement. But yeah, we can get into that in a moment. But yeah, I think that the settings for these things need to be like physical properties, not the usual settings you would find on a delay. After all, this is a novelty. It's not like your go-to delay for a regular 1/8 of a note delay kind of thing.
So yeah, gravity, drop distance, material, and then smearing, blurring.
I think that the actual name for what I'm talking about is the elasticity of the ball. If it is elastic, it is going to bounce back. If it's not elastic, it's going to just fall and stay there. But I don't know. I will have to check this.
Elasticity is one parameter, and also like balls that are filled with air versus a ball that is filled with not air would also behave differently, right? Like a golf ball is kind of the size of a ping pong ball, but it's much denser, so it like falls and doesn't really bounce. It maybe bounces a couple of times.
Yeah, I think that the density of the ball is what we are getting after, right? The density of the ball is not going to affect the rate of the taps. It's because something that is denser is going to fall at exactly the same speed, but it will sound different because it will be louder. When you drop something that is denser, it makes more sound. Because it has more energy, and it needs to dissipate that energy somehow.
Cool. So yeah, elasticity, density, smearing and blurring, pitch changes, I guess, / modulation would be a cute idea. Yeah. So far, these are the ideas.
And all sorts of effects that people tend to put on delay lines. Like we could do a redelay that we were looking at, the beat crushing, and you can do all sorts of saturation.
Just high pass, low pass.
Filtering.
Saturation. What was the other one that you said? Filter. Okay. Yeah, bit crushing would be fun. Cool. And like it wouldn't have a feedback amount, right? That's an interesting part of this delay. I would say it wouldn't have a feedback.
Yeah, the usual settings you find on delays, like the rate and the feedback, and we don't have those. We have the crazy, otherworldly settings. Okay, so let's start by having a delay line in place. So we're going to import my library. We're going to have a delay line in place, and we're going to have one tap just to make sure that everything is wired correctly. And then we'll go into the formulas for calculating the distances between the samples or the sizes of the taps.
So to import a library, do you go before the init phase or do you have to be at the init phase? You can do it before it.
No, you have to be before the init phase. It's part of the description and sliders block.
Is it like this?
It needs to find the right path. So I think that you have a libraries folder. So I think it needs to be libraries / the thing that you wrote, and it is leafac.jsfx-inc, not leafac-inc. -inc is part of the extension.
If I now save, would it tell me if it found the right thing?
I don't know. Try it out.
Cannot find file. Okay.
So it is complaining. I think that libraries was with a capital L, but I don't think that matters because in macOS the file system is supposed to be case insensitive, but it doesn't hurt to try.
Or ReaFIR main and doop 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 doop. Boo boo boo. Oh, we got a couple of libraries here. I should have just not made that libraries, eh? Yeah, fact the JSFX/inc. I'm writing it libraries. I mean, let's try the capital L. What do we have to lose? Can't find the file. Should I just take it out of that folder?
Maybe.
All right. And leafac.jsfx/inc. And can't find it.
That is weird.
Is this a thing? No, that's not a thing. Boo 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 boo. Oh, hold on. Is it possible? Yes, that is what's happening. This is for some reason. No, wait, that's not it. This is the right path. This is the path we are in. We are volumes.
Yeah, we saw the file in Finder.
Utilities. Oh, yeah, you saw it in the Finder? Cool. So what the fork? Is it because of this? Could it be, Leandro? There are spaces in my directory and that's bad?
In my machine, there are no spaces in the path, but I mean, come on, ReaFIR. You should be able to figure this out. In fact, you are able to use, from this ReaFIR instance, you are able to use some other effects that use libraries like the Durand
or
plugins, right?
Like this ships with Bose thing, with Bose effect. Yep. So let's try to import that. Cook dsp.jsfx-inc shiblanks recompiled. Okay. So is there a special type of syntax or something that needs to exist in your library, for example? Could that be a thing?
No. Okay. I mean, can you open the file with the library for a moment just so we can see if the contents are fine there? Because it's complained that it cannot even find the file, and that does not make sense. We are looking at the file right there. And no, the file is intact.
Should I open it with a text, or you just want to see that there is text here?
Yeah, no, that's enough. We can see that the text is there. There is no like HTML or some other kind of junk around it. So it's complaining that it cannot even find the file.
I have a question, by the way.
Yeah.
Not that I'm proposing we do this, but when you import a library, would that theoretically be the same as me just copying all these lines and pasting it in my effect? Is it in essence the same thing?
That is exactly what's happening. In fact, well, to some extent, there are some edge cases that I don't want to get into, but yeah, to all effects and purposes, it is just copying and pasting. In fact, that's what we are going to do right now because we are not able to import the library, but the library is there and ReaFIR cannot find it. It is
one
messed
idea.
Up. Whatever. Let's copy and paste the source code.
I'm gonna scan for new plugins. Cause like if I look up Cook DSP, that's gonna be in here. Or so I thought.
No, it's not.
It's not.
That's the purpose of the. That's the purpose of ink at the end.
So it's not a JSON.
So it does not show up in the effects list.
Okay, cool. So yeah, weird, huh?
Super weird. Have never seen that before. I have no idea what's going on. And in fact, that does not happen on my machine because I have been working on this and I have a demonstration effect that is using the library,
I got it.
Importing the library the same way that you are importing the library.
See, like we stripped the format, but it didn't actually strip the format. I think this will. I think this will do it.
So in Finder, what I do is I always show the extensions of the files because of these issues.
There we go. All right.
But there you go. Now we are able to do this. Awesome. So moving on the init block, you are going to have to allocate a delay line. You're going to have to like reserve some space in memory to store all the samples as they come in so that we are able to tap to them. Or tap into them. I don't know. In any case. So on the init block, you're going to have to write some code. And I'm wondering what is the best way for me to share this with you.
Do you want to get a Visual Studio situation going?
We could do that, but it could be kind of slow. So how about we just try something like an Ether pad?
I don't know what that is, but...
Bose says, come on. It is so complicated these days.
In one sense, there could be a feedback, but it's sped up. But all the modulations like filtering, distortion, etc. gets added for every repeat. Yeah, in essence, right? Yeah, like I guess what we're doing is like when I was using like RIA delay, I had to set the feedback to 0 so I could have every single tap like control over its timing. But I guess if we are writing the thing, it could just be like a feedback loop that is sped up. If that's like possible, provided that wouldn't cause the tape speed up. That would happen with, well, it doesn't happen with RIA delay because RIA delay is digital. But like you could in essence take an analog delay and speed up the rate as the feedback is going, but that would speed up and therefore affect the pitch of every new tap. Codeshare.io. Whoopsie, I missed it. Go to chat.
Yeah, I have never used this thing before, so I don't know how good it is, but it's easier to set up than the Visual Studio Code thing, and I just need to show you like 2 or 3 lines at a time. So I think this will be fine. Let me see if I write here, if you see it there. You see. So first thing you have to write is in the init block, you have to write this thing. And what this does is to initialize the library. And all the functions in the library have this underscore in the beginning. That's a namespacing kind of thing.
By the way, just in case anybody watching is wondering, though I know that only Bo is watching and he knows, Leandro is doing his entire library on live streams, so you can see the entire process. Cool.
Yes.
So I go L... No, that's not L. That's just one. Underscore dot init.
Yeah, that's
ship lamps, ship loops, pap.
Yes, so that is initializing the library. It's just a preamble that you have to have in order to be able to use the library. So now let's actually allocate some space for the delay lines. And do you want to like start simple and just have a mono thing, or do you want to do the loop and do it multi-channel? It's not too hard anyway.
Good question. I guess, yeah, let's just make a multi-channel.
Oh, can you take note of something that I think we should have is the stereoizing thing that you mentioned. You widen the delay.
Widening over time, basically.
Yeah. So, okay. To have this multiple, so we need not only one delay line, we need multiple delay lines, one per channel. And we don't know how many channels we are going to get. So let's, first we have to do a bit of annoying bookkeeping. So you need a serialized block, and it doesn't have to have anything in there. You can just leave it like this, but you do need a serialized block so that the number of channels is going to be available on the init block. I have no idea why this is necessary, but it is. So you can just copy and paste the code that I put on the code share thing. And it's a serialized block that doesn't do anything, but it's going to force a variable into existence. Now, on the init block, so coming back to the init block, we are going to have a delay lines sort of situation. We want to have multiple delay lines. How many delay lines? Well, the number of delay lines is given by the number of channels in the track. And we need to allocate some memory for the delay lines. And I think that the easiest way to do that may be to just allocate some memory. So in my library, there is a memory new function that you can use. Let me double check if that is how you use it.
Memory next available address?
Yes, you can go ahead and copy.
Or memory.new.
No. Yeah, the thing that I wrote is correct.
There we go.
So you can just do that.
And shablams.
And this is just allocating space for the delay lines. Now we need to actually allocate the delay lines. So let's do a loop that is going to loop over all channels. To do that, we are going to start at channel -1, and we are going to do a loop that is going to run for the number of channels. The first thing that we do is to increment the number of channels. So the first time we go around the loop, the channel is channel 0, which is the left-hand channel. Then channel 1 is the right-hand one. And then if you have multi-channel going on, there will be more of these. So now we can go into the delay lines at position channel and allocate a new circular buffer. A circular buffer for all effects and purposes is a delay line. And we need to allocate a new one of these. And we need to know the size of this delay line. So now we are allocating memory. We need to be conservative because when you're writing JSFX, you're doing real-time audio processing. That is something that takes a huge amount of resources from your machine. You're running some code 48,000 times a second. It needs to be fast code. So when you're actually processing the audio, you don't want to change the circular buffer size. You don't want to allocate more memory, or if you change one of the sliders, you don't want to reallocate memory. So we are going to allocate pessimistically. We are going to allocate as much memory as I think we will ever need. Probably more than you are actually going to need, but memory is cheap. CPU is expensive. So we are going to allocate as much memory as we think we are going to need. And then we may use just a subsection of that chunk of memory, but that's fine. Running out of memory is bad.
A circular buffer, in simple terms, would be like it goes like 1,000 samples and returns to the first sample and goes 1,000 samples, and we can like grab it.
Yep.
We can grab samples from it as we need, but then if it like resets, it overwrites that sample, right? Cool.
Yes, you can pretend that a circular buffer is like an infinite buffer. And it keeps forgetting the old values, but as long as you don't try to recall the old values, that's okay. So in a circular buffer, you can just keep pushing samples and you're never going to run out of space, because under the hood, what it's doing is it's wrapping around. That's why it's called a circular buffer. And that's a delay line for all effects and purposes for all that we care. So we want a circular buffer of a certain size, and that size needs to be in terms of samples. We need to say how many samples we want to store. But thinking about samples is usually annoying. So I do have a function that we can use that is called milliseconds to samples, and it goes like this, and you just give it the number of milliseconds that you want to use. So let's say that maybe you are going to store at most 5 seconds worth of samples.
In this case,
worst case scenario.
In this case, because you were saying when it's in, I think it was in your RFT, or sorry, in your DFT thing, you were saying if it's a very well-known abbreviation, you're okay with it. So I would change this to MS to samples.
Fair.
I'm giving user
That's
feedback.
a good point. By the way, in fact, instead of just going with 5 seconds, how about we look at the sample that you collected and we can see how long it is, and we can make a decision based on that.
When you say sample that's collected, like the incoming audio?
Yeah, we recorded a ping pong ball. How long was that recording?
Sure, we can take a look. It's getting a little tight in here with the code share thing. So actually, I'm going to put your code share on my second screen, and then I'm just going to write from it so the users will see what they see. If users think, or if the viewers think that that is cool. You may think I can hide this mixer and get a lot of space back, but actually if I do that, then I will constantly be putting code in front of our faces. So you want the length of this entire thing.
And Bo is saying on the chat something that I strongly disagree with a lot of passion. He's saying MS, the number 2 SPL,
number 2, no.
so MS to sample. I disagree with that because it's so much abbreviation. I mean, MS may be good enough, but then again, when I start doing mid-side conversion, which is something that I have to do in the library, so when I do mid-side conversion, it's also MS. So you see what I mean? Sometimes it's annoying to use abbreviations.
And you can't do like lowercase ms and have a separate uppercase ms, right? That's not a thing because it's case instance.
Oh, I learned that with a lot of pain because in my library, I was using capitalization to differentiate variables, which is something that you can do in most programming languages. But in JSFX, no. JSFX is casing sensitive, and I learned that the hard way, and I had to refactor a lot of code, or actually fix. It's not refactoring when it was broken.
I also overall have
so how long is the sample?
Another beef with SPL specifically because that's also sound pressure level. It's 8.86 seconds. That's the entirety of the thing. I guess it really ends here. So if we really want to be like, you want the whole thing, right? You wanted this whole setup.
Yeah. So definitely 5 seconds is not long enough. Let's go with like 20
seconds. Cool. Strip lamps.
And Frozen is here. Hey, Frozen. Frozen says, I'm so looking forward to your channel growing up as you cover very in-depth level of mixing. You and Dan Worrell could be friends, right?
I would love to be friends with Dan Worrell. That said, I would think I am miles and miles behind Dan Worrell. I mean, Dan Worrell is really on another level. I mean, I've had professors in university that watch Dan Worrell and they're like, whoa. Like literally, I sent Dan Worrell's channel to my old professor, and he was like, he just emailed in all caps, "This changes everything." He's got like a PhD in audio production or whatever. So and produces for like Jamiroquai and stuff. So Dan Worrell is next level. But I would love to be friends with Dan Worrell, and I recently sent a mix to him for feedback because you can become a member of his channel and get feedback from him. So I'm really looking forward to his thoughts on that. But thank you. That's a huge compliment. Thank you.
Right. Okay. So we have 20 seconds worth of samples that we are allocating. We are just allocating this space. We are not actually pushing the samples in there. I think that we are missing the closing parens and semicolon.
Yes, I'm looking to your...
Or maybe it's just in a single line. I don't know.
I'm looking at your code.
No, I think you're missing it.
I got 2 here. I have to have... No, I'm not seeing it. Tell me my mistake. Show me my mistake, Leandro.
line 6 on the code share
line
thing.
6 on the code share. Oh, we need to close the whole setup. Cool. Show up lamps.
Yep, that. And then it recompiled. Okay, so before there was probably a syntax error. So now we allocated all this space. But right now we are not putting any samples in there. So now let's go into a sample block. And we'll have to loop over all the channels again. So we'll do a bit that is similar to the other thing we did above with the looping of the channels. But this time...
Excuse me, plus 39. What country is that? Give me 1 second, sorry. Hello?
Okay.
Ni hao, guy. Okay, sorry. Must be China. I'm somehow in like in the loop of a Chinese telemarketing scam thing, because I had a friend of mine who speaks Mandarin translate it, and it's like, oh, you have this box waiting for you, and in order to have it released, you have to pay this thing.
Huh. How lucky. Okay, so maybe put my code share on top of like the mixer or whatever, so that people can see when I'm speaking out loud here and saying stuff.
The issue is that it will, if I click anywhere here, that goes away. Oh, it doesn't go away. Fantastic.
Great. And so what these lines are doing, when I select things here, you see selected there, right?
Yes.
I think so. Yes. Awesome. So this thing is doing a loop in pretty much the same way we did before, but now it's using this other function called circular buffer push that is pushing a sample, SPL at channel, and it's pushing that sample into the correct delay line. So I'm getting the delay line from the list of delay lines. So we are going to do a multi-channel delay, which I think is somewhat unique. Most delays are probably stereo, but not ours.
No, sorry, Bob.
Ours is multi-channel.
We are future-proofing.
Yeah, so you can go ahead and just copy and paste the thing instead of having to rewrite it. But rewriting it is a good
for
learning
me
technique.
Yeah,
so
I wanna like, yeah.
Yep. You want to get your hands used to the motions, right? So now we are pushing the samples into the circular buffer, which means that we are collecting the samples, but we are not playing them back. We are not doing anything that we can hear or see. So let's do something that we can hear and something that it's just a simple tap. Okay, simple stuff. So what we can do is in this same loop, we can say that the sample at channel plus equals. So when I say plus equals here, it means the sample on that channel, I'm going to mix with, I'm going to add together some old sample that was in the circular buffer a while ago. And to do that, I am going to use another function, another auxiliary function here with the circular buffer situation. It's called get, and I give it the delay line, and I give it how many samples ago I want this from. So let's say that I want this from 1 second ago.
I'm frozen. To answer your question, it is EEL2, which is proprietary ReaFIR stuff, or proprietary Justin Frankel stuff.
Yes, it is open source though, so that much is cool.
So Leandro, let me see if I understand something up to this point. So in circular buffer.new, we create a buffer and we give it this length, and in push we are like grabbing samples from that, or in get we're grabbing.
So let me explain this in detail. On this line here, we are claiming that space. We are planting the flag, but we are not doing anything. Then on this line here, we are building something. We are actually taking this sample, which is the sound coming in real time, and we are saying, okay, delay line, remember this value for me. I will retrieve it later. So I'm pushing the sample into the delay line. Then later, well, in some cases it would be like many lines later, but in this case it's like literally the next line. We want to retrieve some old values that were in the delay line. And to retrieve a value from the delay line, you use this get function. You give it the delay line, and then you say how much ago you want the sample from. So in this case, I'm saying I want the sample from 1 second ago. And we are storing 20 seconds worth of samples, but we are not tapping into 20 seconds worth of samples. We are just storing 20 seconds and we are going 1 second ago, grabbing that, and we are adding that to the current sample, which means we are mixing the current sample. So the dry signal is here, and the wet signal is this one, and we're mixing the two together. So the wet signal is the sample from 1 second ago. So this is a 1 second tap delay. And you have to be careful about this line here. I refactored this line 11. Since we are going to use the delay line twice, once to push and then to get, I declared a variable so that we don't have to access memory twice. And this accessing memory can be somewhat slow and it adds up. So
hold the phone. So I go here, I go down here, and I go.
Yes, right. So while you're doing that, which is pretty much just not copy and pasting, but recreating the thing that is on the code share, I'm going to react to what people were saying because I noticed that there was a question for me. So Bo says, off topic, I managed to write a slew rate thing yesterday. It was a for DSer and it's working surprisingly well. Great, send it our way. We'll talk about it. Still need to wrap my head. The freaking whole code, the whole moving average has been a running theme for us. And Frozen says, especially since he's done videos about some JSFX and found bugs inside them. Dan Warrow did that. And yeah, I sure hope Dan Warrow sometimes, I sure hope that in the future, maybe Dan Warrow is going to find a bug in one of my
That's a dream.
Scripts. Yep.
Cool.
All right. So how are you doing in terms of recreating the code?
Just to clarify something, these are two different variables, delay underscore line and delay underscore lines up here.
Cool, yes, they are different variables, yes. My convention that I actually brought from other languages is that usually if you have a list of something, it's plural, and then the singular is one element in that list. And on the line, I don't have a line counter on your thing, but you can see that here you can use delay line instead of using delay lines at channel.
Okay.
See what I have highlighted?
I guess there should be a way for you to just commandeer my system would be easier, but I actually like kind of writing this because somehow, like when I was in school, I would take notes. Not that I would ever study those notes, but just the act of writing them made them stick in my head better. So.
Yeah, that's a smart move. In fact, there are simple ways of me controlling your text editor, but I think it's better this way. Right, so this is supposed to be working. Let's save this and pass some audio through it, and let's see if we have a delay of 1 second thing going on.
Over here. I think this JSFX right now is not on anything.
Oh, that's great, actually. And in fact, you want to mute the track and mute everything, and we want to see the levels first
before we.
And if the thing sounds okay, looks okay, then we can hear it. But you never want to hear the effect first.
Sorry, wait, hold on. Let me put this somewhere that we can doink it out. So yeah, and now it's 100% wet. So let me just make this like 50% wet. Did that work? Does this look like it's working to you?
Skype doesn't give me a frame rate good enough for me to see the spikes in real time. So what we expect to see is 2 spikes
I
1
see
second
one
apart.
spike, yeah. I am seeing one spike. One spike.
Okay.
I
know the issue. The issue is this. We need a minus sign there. Or at least that's one of the issues anyway. There may be more.
Shablam.
See on line 16 on my thing. Yes,
Whoops.
that. You are getting samples from the past, so the offset needs to be negative.
Okay, that didn't seem to have done the trick.
Can you like save, do a full compile, reset, maybe remove the effect from the track and drop it again? Just make sure that we are running the latest code.
Whoops, and I keep pressing space there. I'm even gonna do that. Shibloinks, shibloomfs. I'm gonna make this not wet because I think right now as it stands we don't have a wet dry control in the effect, so 35%.
Yeah, no, but leave it at 100% wet, because what we call 100% wet in our effect is already mixing in the dry signal as well.
Oh, that worked. There we go.
Great. So now we have a delay line of 1 second. Now our goal is to have multiple taps, and we want to space these taps so that it goes right when the ball would be hitting the table. For that, we are going to need physics and we are going to need math. But first, I want to react to things that are happening on the chat, because there are some questions addressed to me again, if I may. So Frozen asks, off topic and a broad question. Sorry, how do you make a plugin with the JSFX script using only ReaFIR resources? Can you replace the default slider GUI with some knobs? The answer is yes.
Let me even demonstrate.
It's not super trivial, but it's possible. Because I found some lovely reverb, I hope I can create with something similar vibe based on some JSFX code. Yes, absolutely something that can be done. And one of the reasons why I'm developing a library is so that it becomes easier for you to get there. But there are other libraries already with different trade-offs. You can watch my streams to get in more depth into that.
I can show you one such example, which is stuff like this. And this is by Garant Luff. It's a library that is pretty nice. Like, you can make knobs, you can have visual things, but Garant has somewhat like moved on from JSFX, and he's getting into like the VST kind of space. So the library is not maintained or updated, hence why Leandro, among other reasons, is making his own thing. But yeah, totes possible.
Yeah. Yes, there are some great looking JSFX, and I highly recommend this language, as especially for beginners. I mean, you can crank out ideas so fast, and you can see all the variables in real time on the pane on the right. And when you save, it recompiles and starts running your script. Even if you change some variables, it's going to keep the old variables around for you. It's really great for iterating and prototyping. Even if you're going to do something VST later and distribute it for other DAWs and everything, I still think there is an advantage to starting with JSFX. Right, so we have one tap. How do we compute the time between taps in a way that is going to mimic this file there? I was
thinking of doing this. Let me real quick do one thing. I'm going to bring down the sensitivity of this and bring up its shablankcity, I believe is the term. And I could make this a custom action, but I doubt I'd be doing this too many times in the future. So blap, 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 blap. Boop. Okay, now we got to bring the threshold down a bit. Blop, 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 blop. Whoops, we gotta bring the threshold down a bunch. Whoopsie daisy bloop. Whoopsie daisy whap. Blop, blop, blop. Oops, that's a spurious one. Blop, 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 blop. You know what I like, Leandro? This is very interesting to me. That the decay in terms of amplitude is not linear at all. Sometimes it gets a little louder. So that's just cute.
That is interesting, and I don't think we will be able to recreate this effect of getting louder and quieter. I think this is like atmospheric noise, if
Yeah,
you know
it
what I
could
mean.
also be just kind of
But yeah,
distance.
we'll get into some cool
It
physics.
could be like based on distance, because the thing was like kind of moving away from the mic, getting closer a little bit, because the entire
Oh,
city
there
of
you go.
Montreal is crooked. I'm just checking to see if there are more worth doing. I think 38 is good. Okay, let's just or at this point it's really like oscillating. It's going like brrr, you know, if we look at the waveform. It's almost like the distance between them becomes so short that it essentially is irrelevant. So now what we can do is, let's see. I want to do this without having to make time selections between these one by one. So I gotta set my ruler to, let's set it to, what do you think, seconds? I wish there was milliseconds here. So there are samples here.
I think that seconds is better.
Seconds. So, well, this also starts at a weird second. Do you want me to move all of this to the very beginning?
Maybe, if that's easy.
That is quite easy. You go to File, Project Settings. I actually have it right here. I just want it to be accessible, but I've put so many things in weird places that now I no longer am able to find things the regular way. Okay, so I did that, and now we got this. I can even generate this as a
That
list.
is great. I really like this. So you are going about this in the experimental kind of way. And when I was preparing for this, I actually did some reading for this stream. I don't do this off the cuff. In any case, I was doing some reading for this, and I was going to go about this in a very different way, much more like high school physics kind of situation.
I'm so open to that.
So what I was thinking, especially if we want to have sliders for all the properties we talked about, like gravity, we want to compute these numbers. But it's great that you have a measurement of the numbers, because then we can double check our work. But I was thinking that we would use the formulas of motion to actually calculate
Sounds
the
awesome.
taps.
Yeah, let's do that. Is it gonna be, what is that formula? No, it's not F equals ma. I used to be so good at physics until I started smoking weed in high school. And don't smoke weed in high school. Smoke weed. Apparently, if you smoke weed after the age of 24, there's basically like next to no long-term effects. But I smoked weed too early, and trigonometry, goodbye. Physics, somewhat goodbye. Say it.
That's too bad. But I don't remember all these things either. I know where to find them. They are on the internet. So I googled for equations of motion, and here is the link on the code share thing we are using. You can go to the Wikipedia page for the equations of motion. Isn't that great?
Says, can you put that in a spreadsheet? Yeah, you can actually export spreadsheets right from good old ReaFIR, because ReaFIR thinks about more than just musicians. And that is cool. Your file could not be accessed. Why? Because of this. It translates some stuff to hexadecimal situation. There we go. Whoa, that is ginormous.
That's a big article. Man.
Jesus. I'm a little blind. And why is it looking a little bit wonkaroon? Like, what's with this? Oh, there we go. All right. Needed to think about it for a second. Here we are at equations of motion. I'll make this slightly bigger. There we go. Did I lose you, Leandro?
No, I'm here.
I was
reading the
crap in
chat.
school.
Sorry. So specifically, we want to go to the section on constant. What is it called? constant translational acceleration in a straight line. Oh, that's a mouthful. But it's there under it's section 2.1.
There we go.
Yeah, so the cool thing about this formula is that it's a constant translational acceleration. Translation just means that you're moving on the plane, and it is acceleration because Earth is pulling you, it's gravity, and it is a straight line. You're dropping the ball and you're just dropping it on the table. Now, you could throw the ball, but the cool thing about motion is that the motions, the axis of motion are independent. So if you throw a ball, Earth is going to pull it down with the same speed, the same acceleration, gravity. So if you throw it, it is going to go far away from you, but it's going to fall at the same rate.
Assuming negligible friction from air.
Yeah, so when I was thinking about this is we are going to ignore friction, we are going to ignore atmospheric pressure, we are going to ignore imperfections on the ball, we are going to ignore a bunch of things, but it is good enough, I think, for our purposes. No, we're not.
Also, Frozen says, do you want to make a video about configuring ReaFIR's GUI? You should subscribe to this channel, which I'll put in the chat as Leandro goes through the explanation. Sorry, Leandro.
Yeah, so I don't know if Frozen is talking about my library, or if he's talking about you, Aria. You have repositioned a bunch of stuff in your ReaFIR installation, so maybe he's talking about that. But if you are interested in learning more about the library that I'm developing, it's nowhere near done, like Bo said in the chat. But we are developing it together on the stream. In fact, I'm going to... I do a stream every day, and I am working on that library most days. And it is going to be easier to do GUIs using my library.
And if you did mean the ReaFIR GUI, I've already covered some of it, and I'll point you to the playlists. Go to the playlist specials on my channel, and you can see most of them. Anyway, let's go.
Yeah, so there are more than one equation of motion. And they come in all these different flavors. We have 5 of them on the screen. I think that the flavor we are probably the most interested in is going to be flavor 2.
That's the one I also somewhat remember.
Right. Yeah, it is the most familiar to me. But we may want something else. But I guess let's start with that. So can you put my code share thing on the screen? Because I want to explain with this formula what it's doing and how we are going to use it. And I will have to write some things down. So first of all, it's as a matter of preference, because I am explaining this, I'm going to do it my way, which is to not use this R, V, and T variables. They annoy the hell out of me. I think that's how mathematicians and physicists write, but I am a human being, so I'm going to write this as a human being would write. So the final position, I'm just going to rewrite formula 2 with my notation, okay? So the final position is equal to the initial position. In fact, how about we write it like this? We write it as position initial and position.
But the other way around,
This is the final position.
Cool.
Yeah, so I'm writing it using this notation because that's a notation that works in JSFX. Then you add the initial, or maybe the velocity initial, times, this is just time. So that is, okay, I'm going to go into that in a moment. I will explain what that time is in a moment. Then plus we'll have a bunch of things divided by 2 at the end. That's the acceleration times the square of time. Okay, so what's going on here? You have to have your initial position where you are dropping the ball from, how far away from the desk. Then the velocity initial is something that if you're like throwing the ball, then you would have some initial velocity. But we are not. We are probably just letting it go. Just dropping it without throwing it. So the initial velocity is going to be 0. And then acceleration is fixed. That's the acceleration of gravity. The acceleration of gravity.
7? Or let's call it 10.
I think it's 9.8 meters per second.
Yeah, that makes sense. Okay.
Per second. So it's per second squared, right? It's per second per second. So that is fixed. And then time again. So this time situation that we keep seeing is how long it will take for the ball to go from my hand.
I guess should we call it gravity.earth for future proofing this for other planets and that?
Sure.
Cool.
Sure. Why not? Why not? So, well, I guess I would say let's have a gravity variable. And one of the options is to use gravity Earth. So, of course, it has to go the other way around, but for the thing to be defined when it's used. In any case, so this is the formula of motion, the equation of motion that we have. That's what is on the Wikipedia page. But let's start adapting it for our purpose. So I just copy and pasted the thing and let's change it. So what is the initial position? Let's do this in meters because acceleration of Earth is in meters. So let's say that you dropped, how far from the desk do you think you were?
Well, I did it from the floor down. I would say it was 1 meter. Let's just, and it was probably 1 meter.
Okay. All right, so the initial velocity and the time just go away because the initial velocity is 0, right? You didn't throw the ball, you just let it go.
Let it go.
Yeah, so that term is going to go away. And then acceleration we have, it's fixed. And then time and 2, so we already have the position final as well. It's 0, right? So I'm supposing that we have a plane that starts at 0 is your desk, 1 meter is like 1 meter from your desk or from the floor or whatever. And then negative numbers would be like underground.
Right. Ooh. Yeah.
Does that make sense? Okay, so now all we have to do is solve for time. Right? So to solve this for time, one thing I can do is I'm going to start copying and pasting this and changing things around. So this 1 can go to the other side as -1. This plus is now irrelevant. Then this 2 can actually go to the other side by multiplication. And then this parentheses become irrelevant. And then this 9.8 can go to the other side by dividing. And then this square can go to the other side as square root. So now we have a way of computing the time. I'm going to reorder this because I think it makes more sense this way. So now we have a notion of when the ball hit the desk. It was this number after you dropped it.
Right.
Except that it's a negative number. So that, what is that about? Did I like make some
Wait, no, I don't think you made an error, but I think it makes sense to be negative because it's position final, no?
No. I made an error. Arya, I made an error. The error is I specifically said that the desk is 0 and then you drop the ball from position 1. But the issue is if that is your reference, then acceleration is negative because acceleration is pulling you towards 0. So it's going from 1 to 0. So acceleration is negative, which means that we are not working with 9.8. We are working with negative 9.8.
The rest position. when the ball has finished moving. Okay.
Yes, that's your desk. Yeah, so now these two negatives become a positive, and then we can calculate this. And that is the number 0.45. Can you go to your spreadsheet and check?
That should say the first distance, right? The first bounce, it's 0.785. You said 0.45. It's close.
Okay, it's not
definitely
perfect.
It wasn't a meter, right? It was probably like 0.6 meters or something, and I just said a meter to make the math easy.
Yeah, okay. So we are not embarrassingly off.
I'm not embarrassed. Yeah.
So I'll go with that. So that is a computation that we can use to get the time of the first step as you drop the ball. Let's actually make it generic, right? Because you could just hard code this number, this 0.45, or even your number from your spreadsheet, but let's make it generic. So I will rework the way that I got into this equation here. I will rework how I got there, but I'm not going to replace the variables with actual numbers, except for position final. That one is fixed. That's your desk. We are not moving the desk around. But the position initial is a slider. The velocity initial, I think we can say is 0. Let's not have the person be able to throw the ball.
They can already change the gravity, so if they want it like more drastic, they just change the gravity.
Yeah, and then acceleration, I think we're going to leave as a slider, but then we are solving this for time. Time is the variable we are interested in. So let's redo our steps. And I have to make sure that my acceleration is going to be negative, but I'm not going to work this into the formula right now. I mean, we may say that the acceleration is negative, or we may put a minus on the formula. I think we are going to say that the acceleration is positive, so let's put a minus on the formula. And let's work this out.
You have 3 C's in acceleration, just FYI. You have 3 C's in your acceleration. It should be 2, but that could be solved at a later time.
There we go. So let's solve this for time again, but this time with the variables. And this one goes to the other side as negative. And then we multiply by 2. And then we divide by that. And we take the square root of the whole thing. So this is high school physics for you all. And because both of these terms are negative, they can become positive. And there you have it. That's not a bad formula to have on our code. That's the time of the first step in terms of seconds.
Excuse me, I'm just, my landlord is emailing me to let somebody in. Give me 1 second, sorry.
Sure, no problem. So while Arya is taking care of that, I will read stuff in the chat. Thanks for the subscription, Frozen. I hope you enjoy your stay. And I have not watched Frozen, so I'll not comment on that. Okay, so while Ira is still away, I'm going to explain the rest of the logic. So we already have a formula for computing when the ball hits the table, how long that took, how long it took the ball to travel that distance. We already have that, and that is going to be the size of our tap. That's going to be the how many samples ago we're going to replay. But we still need to find the velocity that the ball had when it hit the table, because the higher the velocity, the more sound it makes. And that's going to come up next. So Arya, we are not going to worry about this now. Let's just implement one tap, and we are not going to worry about the loudness of the tap. Sure. It's going to be full loudness. We don't care. But let's implement this notion so that we can tap in the right time. And maybe even let's introduce the sliders real quick because it doesn't hurt. So we can have a slider for acceleration and the initial height.
I'm putting you on the side here again. If at any point anything is in people's way of seeing what's going on, please let us know. Okay, so let me start by writing the formula. I need line 35.
So the only thing you're interested in is 31. This one, okay?
Okay. Let's lose this also for a second. 31 is time equals squirt of position dot initial times 2 divided by acceleration. Swoop, speep, whoops. And I'll just put a little bit of space here too, and I'll even comment formulas for later navigation. And let's just get to the sliders too. What do you think?
Yes, let's do one slider for the position and one slider for acceleration.
Position, what do you think if I call it distance? Height, that's
height.
Yes, thank you. And the height can't be 0, I guess, right? Yeah.
Yeah, dropping the ball without actually elevating the ball doesn't make sense. So let's go from let's say maybe 10 centimeters.
Yeah, until, let's say 100 meters. We don't want to, because even from 100 meters, that'll be how many taps? Like hundreds and hundreds of taps, right?
Well, the issue is for the ball to fall from 100 meters, it takes a lot of time. So our 20 seconds worth of delay line may not be enough.
Let's make it, what do you say, 10 meters?
So let's just do like 2 meters, I think is probably good. Okay, you can go with 10.
Let's just do 2.
And let's give you a step of like 1 centimeter.
So height is going to be in cm. And
well, but you wrote everything in meters.
Oh, I'm dumb. Let's see. What do you think? Let's do. Should I change the values to centimeter or just make this meter? Let's make this meter. And if you're American, why don't you get the hell out of here? No, I'm just kidding. You can.
And I think it's best for us to do everything in meters because acceleration is given in meters and everything.
Acceleration. So for acceleration, should it be like a drop-down menu where you choose, you know what I mean? You choose a planet or a moon of a planet?
That's a good point, actually. Let's look for acceleration in different planets. I was thinking of just having a slider, but your idea is nice.
Baby girl, sorry, I can't let you in there. Your mama's in there. I'm sorry.
Oh, so it seems like the first result on Google is given in G's, where 1 G is Earth's
I can work with
gravity.
that, right? We just times it by 9.8. Yeah, I feel like that's good.
Yeah. So I am going to now paste the link where I found this. It's actually a Google search, so it's not too interesting. I just searched for gravity in different planets.
I got so many pages going on. I will put all these links in the description of the stream for people in the future. There's not a lot of people in the future, but whatever the runes. I think just the planets of the solar system for now should do. I may later go and add all the moons of Jupiter or whatever, but we're not nerds over here.
And it could be nice to automate the gravity. I don't know what that would do to the pitch. So having a slider for that could be cool, and maybe the different planets could be presets. So you could have a situation where you have a drop down, like the different planets are custom, and then you get a slider and you can slide it around.
That idea. Love that idea. So I'm gonna just add these for now as I guess comments.
Yeah, fair. Or maybe just add to the to-do list. There you
go. So for gravity, we're gonna be I guess the default will be 1, which is Earth. And then we can again go to a gravity of just 1/10 of Earth, and up to.
Yeah, that's similar to the gravity of the moon.
And then maybe, what do you think, like 10 times that of Earth? Or let's see, in these numbers, 2.5.
That's
gonna just
gravity,
be 1.
man.
It's gonna be like boop. It's gonna crush the ping pong ball, right? So yeah, let's go to 3 times the gravity of the planet. And the default is 1. And I will call this, and I'll call this gravity.
No, that when you said the default is 1,
that's the step.
That was not the default value. That was the step. And it seems like we need 2 decimal places, so 0.01.
Beautiful.
Alrighty, and then we need a slider block because we need to calculate the time when you change the sliders.
Remind me if the order being like this is crucial, or can sample be above slider? No, slider has to be above sample, right? Sample has to be last?
No, the order is not significant. Okay, so in the slider block, what we want to do is to, well, we have already the gravity in Gs, but we need it in meters per second to plug it into the equation, right? Because we want the thing to be in seconds, not in Gs. So gravity is, well, let's say that the gravity in meters per second squared is equal to the gravity in Gs times 9.8.
Gravity G.
And I am using the gravity G situation here as the variable that you have in your slider, but I recommend that you rename the variable in the slider to be gravity G.
I did that. And I guess height I just called height, but it's position initial.
Yeah, we could rename that in the formula as well, but yeah, you can do that. And then let's go to the formula that you have and remove it from there. We don't want it there. We want it on the slider block.
Shablamps. Shablooms.
Yeah, so a couple things to fix about this is the semicolon at the end of the line that is calculating the gravity in meters per second squared. And I don't think that time is a good variable name because it's highlighted in yellow, which indicates that it's probably a function.
Like not decay time, rest time? So, what do you think about that?
I don't know what to call this, so I would either go with something like aria, or I would go with something like a time of first bounce.
Okay, yeah.
Or something.
Can I just
until I figure out a better name.
Bounce time. Cool.
There you go. That's good.
Should it be bounce time 1? Because we will have more bounce times.
Aria.
Pseudo object.
We have a variable called acceleration, so maybe the gravity ms2 could be acceleration.
Acceleration is gravity.g times 9.8, gives us meter. Plug that in there.
And then you don't really need gravity.g, it can be just gravity.
There we go, cool. Shablanks, boop. Cool.
And we worked with the formula where acceleration was negative, so we don't need to negate this value. Am I right? Yes, I am right. So I put a minus in there. So that's all right. And then the bounce time 1 is given in seconds, but we need it in terms of samples. So we can use our milliseconds to samples formula, auxiliary function.
And to samples of this situation. Am I writing it right?
No, I think that what you want to do is to call the milliseconds to samples on the right-hand side, not on the left-hand side of the equal sign.
Because a variable is just a variable. And another, something Bo is saying have a ratio of what? Ratio of like bounce time against itself? Is that what you mean? Or I'm not sure what you mean. Or do you know, Leandro?
I think that's the intent. So the second bounce would be a golden ratio of the first bounce, or the first and second. The timings between the first and second bounce. In fact, would
wouldn't it be interesting
right, so
if this already the problem is was that, as such?
I don't think it is. It's more a quadratic thing. But yeah, all right. So there is an issue with the formula, which is milliseconds to samples work with milliseconds, but the formula gives us the timing in seconds. Well, I think we multiply it by 1,000 because there are 1,000 milliseconds in a second, right?
You are indeed correct as usual. And I have to put this whole shiblam Saruni in another brackets, right?
No, I think that the multiplication by 1,000 needs to occur before we call milliseconds to samples. So it needs to appear right before the square root.
1,000 times Coolio.
And can you like save real quick to see if everything is compiling, if we didn't forget any semicolons? Yeah, compiled first time. So now we have this bounce time 1, which is given in samples. We can just go ahead and use it on the line that is doing the fetching of the sample. So the line that reads circular buffer.get. We can, instead of calling milliseconds to samples of 1,000, we can call just use bounce time.
Correct?
No, way below. Right next to the end of the sample block, there is this milliseconds to samples of 1,000. We can remove the whole line because we have already converted to samples. So we can just use bounce time 1.
That's great. I'm even going to put it on the same line, right? Coolio.
Yep.
Even I'm going to do this. Though probably we'll later need to add some extra stuff there, or I don't know.
Yeah, so save this and put it in some track that we don't hear. Just make sure that we have a bounce, that Beautiful. It's bouncing once.
Easy girl. My cat is lashing out. Okay. We had a ball drop on this person. Give me 1 second just to get my cat what she wants. Baby girl, come here.
Come on. Little chair for you. Little nice little chair. Come on, baby. Okay.
All right. Yes, so we got that over here, and let's open this. And looks like this hasn't recompiled or nothing, so I'm just gonna do one more ball drop. I'm gonna do something real quick because I know we're gonna be doing this 1,000 times. That's fine. Did that work?
I don't think the meter is coming back up, is it?
No, it just went up and didn't come back. Maybe let's change the height so that it will be faster.
Well, making faster, if the two were so fast that they were on top of one another, making faster is only going to make it worse. But can you click on edit? Because I want to see the variables.
Whoopsie daisy, that's big. Oh, you want to see the variables on the side here? Whoopsie daisy. Whoa, lots of stuff.
Specifically, I want to see
9.8.
acceleration. Acceleration is supposed to be 9.8. That is correct. Then I want to see our first
huge.
bounce.
It's
So bounce
26,000 seconds. So it'll be after we're all dead.
No. That is given in samples, Aria. That's given in samples. So your sample rate is 48,000, and this is about half, I want to say.
Half, so should be.
That's not too bad, actually, because we did the formula by hand and we determined that it was supposed to be 0.45, right?
For some reason, the output was plus 119 for a second there. But no, it's definitely not. It's definitely not like a half second thing. Wait, what's going on here? No, nothing. Yeah.
Can you scroll down in the code? I think I know what the mistake may be.
Yep. Scroll down. Expand.
Oh, so again, the bounce time is given in samples. It needs to be negative because we are going back in time. So in the circular buffer.get line, almost the last line in the sample block, this needs to be minus the bounce
like
time.
This, or should I do minus 1
because we are going to the yes, exactly. No. Like that is perfect. Can you save this and recompile and make sure that everything is fresh?
There we go. That worked. Boop, boop. It did a boop, boop.
Alrighty. So it is bouncing once. And Bo is asking, are you hearing the delay only? Not really. I think that we are hearing both the initial. Yep. And it seems to be working. Can you patch that so that we hear this?
Whoa, that was good.
See?
Yeah.
It bounced. Can you like render this to a track?
I'm gonna do it the dumb way. I'm gonna do it the old school way, let's call it. I think we already set this up, but maybe not. There we go. Pop, 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 pop.
And can you put this next to the original recording to see if how well we are doing?
I think these are the first two bounces. I want to go to the one that's a full Shawaxarone. Oh wait, but I played with this stuff. Let's, I guess, not play with this stuff and print one more time. Sorry. And I'm gonna actually print mono for now. Print a Rooney, mono Rooney. Boop. Hey, if this is exact, huh? Forget about it. It looks very close. No, it's actually much not close. So I guess we are assuming that I just threw 1 meter as a number. I should have measured the distance so that we can test. But yeah, so we can't assume.
Yeah. Okay. So I'm gonna say the following. I have to leave now, so I'm going to tell you what I plan on doing next on this effect. And then as homework for this effect, can you like measure and then do a recording where you measure, so we have something closer to see if our equation is going to be right. And of course, it's never going to be perfect because we are ignoring so much.
You want to be close, yeah.
But it should be relatively close, I think, in any case. So what I think we should do next is, we already have the first bounce. So to do the second bounce, we're going to do something very similar. We will have to pick some elasticity. So elasticity means when the ball falls, how much of the energy is lost as sound and how much of the energy is used to bounce it back. So we'll have a slider for that. Yeah, Bo says that we haven't taken air resistance into account. Yeah, we haven't taken
we're not going to be super scientific with this, because ultimately it's again a question of, we want this to be usable. So if the user has to set the entire laws of physics into motion before using the delay, they're just not going to.
Yeah. And are you doing this in Machu Picchu, or are you doing this in Holland? It makes a difference, right? So air pressure makes a difference. In any case, so we have the first bounce, and we are using these equations of motion to determine the time of the first bounce. So we also need to determine the velocity with which the ball is falling on the desk, because the higher the velocity, the louder the sound, and the more it will bounce back. So we need to determine this velocity, and we can use another one of the equations of motion to determine that. Then we need to we are going to let the user pick the elasticity, and then we need to compute the next bounce. And the next bounce is interesting because it's going to go up, and then it's going to pause for a split second, and it's going to come down again, right? That's what the ball does. It goes up and then back down. So we need to compute how long it will take to do that, and at which speed it will get back. Well, the speed is actually trivial because we are not considering anything that would take away from the energy. We are not considering air resistance or anything. So the velocity going up is going to be exactly the same velocity coming down. And then with all of this, we're going to write a loop that is going to keep iterating on this to find all the taps we need up to 20 seconds, or when it becomes so quiet that you cannot make sense of it because the velocity is super small, then we can stop as well. So then we will calculate a bunch of taps, not just one, but we are going to do we are going to compute with a loop and some equations and physics the thing that you did by hand in read delay. With all those steps, we're just going to compute all of them using mathematics and physics.
I would also say, and then scaling all
we'll
this
see
stuff,
how that sounds.
If this is easy to do, to fall on a certain grid at the expense of it no longer sounding like accurate. But if somebody wants these rates for the first one to be half measure and then the second one to be just a half note, or start with a dotted half note, then half note, then quarter note, then dotted eighth, something like this.
Yeah, so that's something that we can do up to an extent, right? Because, for instance, say that you want the first bounce to be a quarter note. That is easy because we have a formula that we use to compute the time. Given a certain height, we calculated how long it took for the ball to fall, but we can use it the other way around, and we can say, I want a quarter note, which is like, let's say, a quarter of a second. So you can compute how far up you need to drop the ball for it to take a quarter second to hit the desk. So we can just use the same formula backwards. And you can even do something like, I want the first bounce to be a quarter note and the second bounce to be an eighth note. You can do that because you can determine the height, and you can also play with the elasticity. So you can make it, you can make the ball bounce more or less so that it's gonna hit the desk on the eighth note after the first bounce. But you cannot do that forever because you only have so many variables to control, right? And it may not even matter as much because after the second bounce, or maybe let's say the third bounce, I don't know how long we can take that strategy, but then it becomes so quiet, or it becomes just a pitch or whatever, so it doesn't matter all that much.
I gotta dig into my old school papers. I did a calculation of how long you can keep this musical, and if you start with a whole note, and then if you also get into like quintuples and septuples and shit, you could keep it technically on a grid of some sort for a while. So I'll pull those up. So let me add that also. Pull up the paper for bounce music.
And Bo is saying something interesting. Balls are surprisingly air resistant. I am surprised by this. I thought that balls would be very aerodynamic because they're all round, while something more square would be more air resistant. But, I'm not a physicist, so maybe we will have to model air resistance as well, which is not a huge deal. The whole thing about air resistance is that when we put it on the formula, it is going to take away some of the energy of gravity. So there is a vector pushing the ball down, which is gravity, and there is a vector pushing the ball up, and that vector is proportional to the speed. So the faster you go, the more air you're going to find on your way, so more air resistance is against you. So we may need to model that. I don't know. If we can make something musical without modeling attrition, then we will. But if we need attrition, then
ultimately
we'll put it on the formulas as well.
or
but the
whatever
principle is the
like
same.
a bigger goal than even accuracy, right? Like if we're not accurate, I don't care too much.
Yeah. The main point is it needs to be musical and it needs to be fun. But the principle, even if we want to model everything, the principle is still the same. We are just going to have a big delay line, and we are going to compute the taps, both in terms of how long we need to tap into and how loud. And then we are off to the races. And Bo is saying that I'm wrong, and a profile of an airplane
That's true.
wing is
Otherwise, it
streamlined.
would be a ball, I guess.
And yeah,
I guess
that
is
makes
it
sense.
like a ball
And
has
the
like
dimples and golf balls
infinite points of collision because it's a circle, or if it's a sphere?
Well, not infinite
Right,
because of
yeah,
atoms.
but you know.
I guess yes, you're right. Okay. So that's all I have time for today. But that was good fun. We actually used physics and mathematics. It was. I had a lot of fun
like that
doing
we
this.
said, oh, this one's gonna be trivial, but as ideas kind of bloom, they always become more complicated. But I think it's fun. I hope everybody had fun.
And it's not too crazy. I mean, I took my time explaining all things, and we derived this from the equations we found on Wikipedia. But it's one line of code, people. It's not that hard. And it's not even a complicated line of code. It's just a square root, a multiplication, and a division.
Thing, Leandro. Here's a to-do list. I want to, now that we're talking planets and shit, I want a nice, like not like, you know, insanely nice, but it'd be nice if we could visually indicate a ball dropping. That's all I need. And then we can put an image of the solar system in the back. Oh, I will be so happy.
Yeah, we can find one of those public domain images of the solar system that NASA does.
You can create a
we can select the planets
where the ball just drops like on an axis, right? Like that should be trivial. You already have in your library like systems in place to do that. It just has to plot like the ball hitting the table.
Yes. So when I thought about the user interface for this, I thought, well, I will take a minute to explain the logic behind this. The one thing that I don't like about graphical user interfaces for many things related to audio is how they only show the instantaneous effects of something. So if you have an EQ, you see the instantaneous frequency of the spectral analyzer of that audio coming through instantaneously. And if you have a compressor, you have a gain reduction slider. What I don't like about this is that human brains have a hard time in making a picture out of single frames. So I think it's much better if you have something like Pro C2, a compressor by Feld filter that shows you gain reduction over time. And if you have an EQ, I think you should have what is it called? A sonogram, a spectrograph? I forget the name, where it shows the frequencies with different colors over time. I think that's actually what you need. And RX does a good job of showing you the frequencies over time, and you can see the effect that you are imparting into the audio when you do that. So that said, I thought we could have a ball dropping, all right, but I think it would be nice to show a graph of position of the ball over time, so it becomes like a doop, doop,
that's how I was
imagining kind of thing.
It, Cool.
Yep. So yeah, one thing that I think many plugins are missing in terms of visualization is, even if they have something as simple as like a needle for gain reduction, that's great, actually. Just plot it over time, and I will probably be happy. I will be able to see the pumping. I will be able to see the transient being choked and all those things. So as a beginner, that's what I need.
I have another like philosophical question. We can leave it for later. So I'm just gonna actually like try to word it in a way that I remember it. Is each sample a ball? Do you know what I mean? Like, what if we have a pad? Are we treating every sample of the pad as a new ball? What I would like to do is take a window,
Yes.
like take a window of X samples. It could be like a 1 second, and that's a ball. You know what I mean?
Yeah, another thing that I was thinking about this that is related to that is we could detect transients, and then we only apply the effect on transients. So this will have a different aspect. It will sound different when you have a note that is not a pad. You're not holding the note forever. But if you have longer notes, the beginning of the note may do the bouncing thing, but the decay of the note will not do the bouncing thing.
That is fantastic.
And I don't know how that's going to sound like.
That's kind of how I imagine that, meaning like the thing that you play, right? Coming back to musicality, the thing that you play, the first thing that I play, that's the first drop of the ball, and then it bounces. So it's like pound, 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 pound.
Mm-hmm.
Woo, I'm excited. All right. Well,
Yep.
we'll let you go now that we're at 100 playbacks and we're at exactly 2 hours. Thanks everybody for watching. Thanks Bo for being here the whole time, and a lot of people came and went. But thank you, and see y'all later. Meaning later being.
Are we doing a stream together on Monday, Arya?
Yeah. Actually, yeah. Do you want to do that?
All right, so we're going to be continuing
on Monday,
this, right?
And then we're going to keep going on Mondays. This Friday was a special one. Sorry, John Tidy. I doubt we took any of your viewers, but it was just a dick move on my part to have the stream here. I'm going to come over. Hopefully you're still streaming. I can catch a little bit of it. Any last words, Leandro?
Thank you all for being here active on the chat. Thanks for subscribing to my channel while you were watching this stream. Thank you, Ari, for having me over, for giving this idea in the first place, which I think is such a fun idea and novel too. I don't think there is any other delay that does this. And thanks for helping me do this. I mean, you are the man coding the thing. I'm just on the sidelines cheering. So thank you very much for this opportunity, and I see you on Monday.
All right, take care, everybody. Bye-bye. And I'll put a little bit of this in there, and I'll end the stream in there, and we are out.